I made a video last week detailing some Whittle's initial kind of functionality. So I made a first demo on Whittle, but I made a lot of changes to Whittle since then. So I'm gonna make a second video just to keep you guys updated on what Whittle is doing. But essentially now, the Whittle no longer automatically saves files, so that's the biggest change. But Whittle does generate pretty much all the necessary files you need to run most simple OpenFOAM cases. I also added some functionality to get Whittle to be solver agnostic. Unfortunately, right now it still only considers OpenFOAM, but in the code it's set up to be solver agnostic. So I'm hoping eventually that we can add some other open source solvers like SU2 or whatever else is out there instead of just OpenFOAM. But right now it's still only available for OpenFOAM. And the big reason that I decided to make it solver agnostic is because I realized OpenFOAM isn't the only thing people use. And this also is an open source software. So I figure if there are some commercial solvers that have APIs or Python APIs, it would probably be beneficial for people to be able to incorporate Whittle into their CFD workflows using those APIs, if it's possible. So I just wanted to make Whittle solver agnostic. And then the reason I got rid of the file saving functionality is because, one, it was useless most of the time. Two, file saving was really hard to incorporate into that kind of solver agnostic framework that I was just talking about. Three, it was contributing to a lot of software bloat. There were a lot of modules that I built to handle the file saving, but they ended up becoming very large. So these kinds of plugins were super annoying to deal with when doing the file saving. So I got rid of that functionality, and then I also changed the default model from GPT-4o Mini to GPT-4.1, which is a little more expensive. I think it's like $8 per 1 million tokens or something like that, which, it's not that cheap, but I think for most CFD workflows it shouldn't be too expensive, but it's also a lot more accurate. So just real quickly, we can run. Oh yeah, sorry. This is the other thing, is that you now have to type in test case to actually get the test case to run, and then if I can spell Whittle right. Okay. So of course Whittle shows up like last time. And if we just wait a minute for it to load, GPT 4.1 is pretty fast at generating files and commands. Okay, so you can see here the biggest difference is that I now have kind of an example response. This is probably a little bit too, for the CLI is probably not very good representation of what a response would actually look like, but this is just an example of answers. And then obviously the questions that were showing up last time to try and get requirements out of you. But essentially, if we just want to say, essentially if we just want to say simulate flow over an NACA 0012 airfoil, incompressible Reynolds number 1 million. We'll say start at 0, end at 100, and our delta t will be 1. And then you can always provide your own boundary conditions. I'm just going to say computational resources are limited. Determine my boundary and initial conditions for me, just for simplicity, because we don't have an actual real problem. So we'll let this again generate its response. Shouldn't be too long, but in the response we're going to expect all the necessary files to be generated. So that would be a control dict, a block mesh dict, the FV solutions, the FV schemes, as well as the some files for the initial conditions. And then remember, I got rid of the functionality for actually saving files. So here's a generator here. Okay. But I got rid of the functionality for automatically saving files. So you actually now have to copy paste the contents of these files into your own files. So I did that last night in VS Code with a particular dictionary file and initial condition and boundary condition files that were generated for me already. So if I just run that, you can see that the mesh is well generated. So that's what Whittle is now. So not much different. It's just you have to now copy paste your own responses into the files instead of automatically saving. Trust me, it's much better for code maintainability. In the future, I have some to-dos. I know the biggest thing is getting Whittle to actually run the post-processing as well as the case itself. So I want it to be able to actually run the case depending on the solver that you choose. So right now it just runs the mesh, but I want to get it to actually run the whole case, and then also do some post-processing. And then I think the next move after that is to move from a CLI to a GUI. So I think a GUI would be very beneficial. Try and get it to be, I don't know, more user-friendly a little bit. I think the CLI is user-friendly, but I think it's a little bit clunky. I just cleared the screen, I forgot. But I think it's a little bit clunky, kind of hard to see results sometimes, and copy-paste isn't as good. I also want to move away from like commands and CLI commands and moving more towards like buttons and things like that. And that'll be good for in the future if people want to run, geometry generating as well. So, Whittle's going to eventually become an AI engineering agent, a full engineering agent. So it has to be able to do some optimization, has to be able to do some CAD stuff. So all that stuff is much better in a GUI, of course. So I think as long as it runs OpenFOAM cases, then that's it for the CLI. And so once we get these to-dos done, we can migrate it to a GUI. So that's the current state of Whittle. And then that's also some ideas for the future of Whittle as well. So again, I'm still looking for contributors. No one has contributed yet, which is fine, but I'm really open to anyone's input. So if you are interested, please send me a message.